we should know what is a data warehouse and what type of data warehouse we have, and how can we use that data warehouse, and how can we use that Datastage or Informatica tools to populate this data warehouse. So before going into the tool, just I would like to explain you briefly about a data warehousing fundamentals, few of the fundamentals.
Okay.
So first of all, what is the data warehouse, and then properties and the architecture, different architectures of the data warehouse, and then there are different schemas of the data warehouse. So what is the data warehouse? First of all, data warehouse is basically, it's a database. It is also a database, but it is a huge database, specifically designed for analysis purpose, but not at all for the transactional purpose. So I have a question here. Do you have any idea on the difference between data warehouse and the data warehousing?
No.
No?
No.
Okay. It's very simple actually. So normally people think that data warehouse, data warehousing, both are look same almost. It's just a continuous form looks like. But a data warehouse is a database. It is a database where we store the data. It's a tables and will be connected with multiple connections. And coming to the data warehousing is a process of constructing the data warehouse. So if you want to construct a data warehouse, so first we should identify what are the different tables we require and what are the different connections between these tables and the keys, indexes. There are number of parameters are there, right? To follow this step-by-step process is called as a data warehousing.
Okay. And
coming to the properties, so basically there are 4 properties. I think you might already aware: the time variant, so and the non-volatile, integrated, subject-oriented. So I'm not going in detail. These are the properties. If you pick any one, like the subject-oriented, what does it mean by subject-oriented? Means it supports the subject-oriented concept. So we can maintain a specific subject-related data in a specific data warehouse. Like if you see an organization might have different departments like sales and purchase and some inventory. So we can maintain a separate data warehouse for a separate sales. It's a subject-oriented. And integrated. What does integrated means? Integrated means the main advantage of the data warehouse is we can read the data from any type of the sources and we can integrate into a single data warehouse. Like we have 4 sources. The one source is the SQL server, one source is the DB2, one source is something like the mainframe database, one source is like the COBOL files. So we have an option to read the data from all those 4 different type of sources, and we can integrate it into a single data warehouse. This is called as an integrated data warehouse. And the non-volatile. Non-volatile means once the data entered into the data warehouse, it will never change, because this is not for the transactional purpose, this is the analysis purpose. Once we enter the data, I mean the subject related data, it will never change. So like for example, take an example of the bank. So when we create a bank account, so my address is, it's Bangalore. Okay. After some time, I want to change from Bangalore to some other location like Mumbai. So when I change my location, my address, then I will go to the bank and ask the bank people to change the address, right? So normally they don't directly replace the Bangalore with the Mumbai, because they should maintain history in the warehouse. Because of that, they will insert another record with the current address like the bank, like the Mumbai. Okay, so in the data warehouse we will have 2 records. The one record is with the Bangalore and one is with the Mumbai. This is called as a non-volatile. And coming to the time variant, so based on the different time periods, we can analyze the data. Like if we consider there are 2 banks, one is the ICICI, one is HDFC. if they wanted to compare the results between the last 6 months, they can compare by using this data warehouse data. It is called as a time variant. So based on the different time periods, they can analyze, they can compare, and they can make the decisions by using this data warehouse data. So these are just basic properties. Apart from there are a number of different properties we have in the data warehouse. These are the basic few properties we have. Any questions?
No, not so far.
Ratnaz, am I going faster, or do you have anything to say?
Actually, no, you're going at a very good pace. I like it.
Okay, thank you. And coming to the architecture. So the architecture of a data, it's just a basic architecture. If you see in the left corner, there are data sources. There are 3 different types of data sources. We can see the operational systems and the operational system, the second one, and the third one is the flat files. 2 categories here. 2 operational systems I have connected, and 1 flat files I have connected to the data warehouse. If you see, we can read the data from different sources here, operational systems and the flat files, and we are loading the data into the data warehouse. So within the data warehouse, you can see there are 3 boxes. One is the metadata, and one is the summary data, and third one is raw data. So what is metadata? Do you have any idea? I think you already completed informatics, so you should answer this question.
It's information about the data. Is metadata.
Sorry?
Information, data about data is metadata, right? Information about the same data.
Right, exactly the bookish definition. Can you give me the clear picture? What is? So I'll tell you what is metadata. Metadata is nothing which is structure of the data. For example, if I write, let us assume there is a board. In the board, I just written just 20. What is the 20? Do you have any idea?
No.
No, right? So on top of the 20, just I written is. So now what is the 20?
You wrote what on 20? One
Is.
second. Huh? One second.
Yeah.
You want question? Yeah, go ahead. Sorry.
No issue.
Yeah. So on 20, you said you wrote.
First I just written 20.
Mm-hmm.
So you cannot guess it, right? What is this 20? This 20, the 20 may be my age, 20 may be my salary, 20 may be the today's date.
Okay.
It's guessing. We don't have a proper answer, right?
Mm-hmm. Yeah.
Just see here. I just written it as a age. What is this 20?
20 is your age.
Yeah, it's an age. So age, whatever I written on top of the 20, it's called as a metadata. It's structure of the data.
Okay.
This is the most important. Without structure in IT industry or in any real world, we cannot identify what data it is. Right?
Okay.
So this is the structure. Not only the name actually. So it's a name and the length of the age, the nullability. There are different things in the database, right?
Mm-hmm.
So whether it is a foreign key, primary keys, all these things are comes under a metadata. It's a structure of the actual data.
Okay.
And coming to the summary data. Summary data means sometimes while reading the data, we have to manipulate it as per the business requirement, and we have to summarize the data and load it into a data warehouse. For example, consider an ATM transactions. We have a bank account with HDFC. So in a particular day, I have withdrawn around, there are 10 transactions I made. So each transaction I have withdrawn 100 rupees. Okay, 10 transactions will be stored in the transaction system, but while loading into the data warehouse, it's analysis data, right? We will summarize it into a single transaction. So what is the actual balance after completing the 10 transactions? It's a summary. Summary will be loaded, summary data. And coming to the raw data, sometimes we may require to load the data as it is. Like whatever the data in the source, we just pick it and load it into a data warehouse. It's a raw data without changing anything. Okay, it's a raw data. These are the different 3 kinds of data we have in the data warehouse. And after loading the data into the data warehouse, the analysis people can extract the data for the analysis purpose. The analysis in the sense here, the high-level management of any organization will come into the picture. They will just see the data. So what we have, if you see the CEO of some XXX bank, he wanted to see how the bank is running in the last 6 months. So they can look into the data warehouse and they can see the data, the analysis people. And reporting. So we can generate the reports like as you already know, Cognos. So we can generate the reports based on the Cognos, business objects, any of the reporting tools from data warehouse. And then data mining, it's an advanced technology. So few of the organizations are using data mining, and they will connect to the data warehouse to predict the future results. Data mining is nothing but it's a predicting the future results. So how the organization is going to be performed in the next 6 months or in the next 1 year based on the past results.
So data mining is possible with Datastage?
No, it's not. These right side parts are not part of this.
Okay.
These are just the input of the data stage. After loading the data into the data warehouse, who are using the data warehouse?
Okay.
So this is the basic architecture of a data warehouse. Okay.
Mm-hmm.
Questions on this?
Yeah.
Any questions I'm asking?
No, I have no questions.
Okay. Thank you. The next one, this is also one of the architecture of a data warehouse with the staging area. Architecture of a data warehouse with the staging. You can just read the heading with the staging. So before going into this one, what is the staging area? Why it is required? So basically, a staging area is a temporary storage location where we store the data if required. This is not mandatory in all the organizations. Sometimes it is required. So why it is required? I'll explain you. Let us consider an organization. So again, consider a bank. So consider HDFC or something, some XXX bank. So banking is a 24/7 application, right? So there are a number of transactions will be happening at any time. So there are mobile banking, phone banking, online banking, direct hard banking. So there are different banking operations there, right? It's a 24/7 application. So all the data present in the transactional systems in the sense they are front-end OLTP systems. So we have to pick it up and we have to load it into the data warehouse, right? Finally, at the end of the day, most of the organizations will read the data at the end of the day and process it into the data warehouse. So what they will do is normally in the real situation, they will allocate a particular time, like in the midnight 2 to 3, or 1 to 2, they will have less number of transactions. So that particular point of time, they will read the data. Only that particular point of time, they will give the access to read the transaction system. So this backend people will read the data in that particular time. So why this staging area is required is, so within that particular 1 hour period, we may not read the data from the data source and load the data into the data warehouse, because in between the data source and data warehouse, we have to perform some business logics. We have to apply some summarization concepts, some arithmetical operations, some business logic. We have to apply different things, right? So it is not possible in 1 hour we have to complete all these process. Because of that, what we do normally is we read the data from a source and we dump it into the staging area. It's a raw data. Whatever the data in the source, we will just dump it into the staging area. Just reading and loading. Reading and loading, it won't take much time, because we are not performing any business logics here. We are not applying any business logics. We are not performing anything here in between the source and target. We are simply reading and loading. So for that purpose, we will use staging area as a temporary storage location where we will dump all the source data. Okay?
And we will not use any business logic there?
No, we will not use any business logic between the source and the staging area.
Okay.
And after loading the data into the staging area, again we will read the data from the staging area. That means our input is now staging area, we will consider it as a source. Because whatever the data in the staging area, it's same as the data source. And most of the organizations will follow the same structure. So both will have the same structure too. Staging area and the data warehouse, both have the same structure. They don't change the structure as well. And we will use the staging area further as a source and read the data and load the data into the warehouse. As I explained earlier, the metadata, summary data, raw data. So these type of data again there in the warehouse. And then the end users, like explained in the previous slide, analysis team, reporting, mining people will extract the data from the warehouse further.
Okay.
Questions?
No, I'm good.
Okay. This is the one type of the architecture of a data warehouse.
Okay.
Coming to the third type. There are basically three categories of architectures. This is one of the typical architecture of a data warehouse with staging and with data marts. So again reading the data from the sources, and now we are using a staging area to dump the data, and then reading the data from the staging area and load it into the data warehouse. After loading the data warehouse, earlier if you see the previous slide, after loading the data warehouse, the end users are analysis team, reporting and mining. Here you can see in between the users, in between the users and the warehouse, we have a data marts concept is there. So first of all, what is a data mart? Basically, a data mart is also a database, but which is specifically designed for a specific subject area. Like it's not like a data warehouse, because data warehouse will have the enterprise level data. It's an organizational level data. We will have all the departments data. Coming to the data marts, we will have data marts will talk about a specific subject area, like the purchase details will be present in one data mart, sales will be one, inventory will be another. So it talk about a particular subject area. This is called as a data mart. So data mart and data warehouse both are same. Data mart will have less quantity, less in size, very less in size. Data warehouse will have a huge in size. Both are the databases only.
Okay.
So after loading the data into the warehouse, we will just split the data based on the different subjects and create a specific data marts. Like all the purchase data will be moved to the purchase data mart, and sales data will be moved to the sales, and inventory will be into the inventory database. So why we are moving the data into a separate data marts is, if a reporting people wanted to read the sales data, they don't need to scan the entire data warehouse. They can directly just go into the sales database and they can pick up the data from the sales. The reporting or analysis or mining, the results will get more faster if they use a specific subject area as a source. So that is the reason we are just maintaining, and we don't actually, not all the organizations maintain the warehouse and marts. Only few organizations maintain the data marts, because whatever the organization is very big and the enterprise data is very huge, then they will split the data into the separate data marts. Then it is very easy for the reporting people to read the data from, or analysis people also, it is very easy to analyze the data. So this is one of the typical architecture of a data warehouse. Any questions on this?
No, I'm good, thank you.
Okay. So coming to the data warehouse schemas. So before going to this one, so why we are discussing all these data warehouse concepts here? So why it is related to the data stage? So where we are exactly coming into the picture is in between the data source and data stage. There is an arrow, right? There is an arrow from the data source to data staging area, right? There are different arrows.
Mm-hmm.
And the arrows, the ETL part will coming into the picture, like the data stage informatica and some MicroStrategy, some other ETL tools will coming into the picture on the arrow. Arrow means in between the work of the data stage is moving the data from source to target. This is the Datastage always do. It's a ETL, right? It's ETL technology. Extraction, transformation, and loading. So extracting the data from the source, and if required, do some transformation and load the data into the staging area or data warehouse anywhere. So it's in between all these, it's in between each category, in between data source and staging area, and in between staging area and the data warehouse. Coming to the schemas. So why do we need to discuss the schemas here is, so we are discussing about a data warehouse design, I mean the architecture. So how can we define this architecture is based on the different schemas we can define a type of the data warehouse architecture. So data warehousing schemas, there are three categories of schemas actually. So you can see the definition of a schema. It's nothing but it's a collection of the tables. Collection of tables is called as a schema. So we can we have to identify the different tables what we require in a particular data warehouse, and we have to establish the connections between each and every table. This is called as this is nothing but a schema. So there are three types of schemas we have. One is the star schema, snowflake schema, galaxy. There are three schemas. Coming to the star schema. So a star schema will have a centrally located fact table and surrounded by the dimension tables. Do you know the difference between a fact and the dimension? Have any idea on the fact and dimension?
I think dimension fact table is the one we have actually done some work on, like calculations.
Okay.
And
yeah.
I don't know what is dimension table. I just know it as dimension table. That's all.
Okay, no issues. And as you said, it is right. The fact will have the most of the numeric numbers actually. So where we do the calculations, like if I want to explain a definition, a fact table is nothing but a fact table will have a numeric data, but every numeric is not a fact. So some of the numerics, I mean, does not belongs to the fact also, even though they are in the fact table. So why I'm telling is, for example, if you see, there is a serial number. The serial number of a particular student is not belongs to the fact because it doesn't identify any performance of the student. So whatever the keys, I mean whatever the facts which are used to identify the performance of a particular object, those are nothing but a facts. For example, there is a mark sheet. In the mark sheet, in the mathematics he got 90 marks. So by using that 90 number, we can identify how the student is studying and how the organization is treating the mathematics and how he is going. So we can identify the performance, right? So those type of numbers are called as a facts, but not the serial number. Serial number, it's just an identification of a particular student. It does not require to evaluate the performance. So a fact is a numeric data, but every numeric is not a fact. Only the numerics which are used to identify the performance of the student, performance of any of the object. Coming to the dimension. So a dimension is nothing but simply a descriptive data, the description of the object. Like if you see an employee data, the employee salary is a fact, and the other details like the employee name, employee number, employee address, employee gender, and the family details, all these belongs to the dimension table, the employee dimension table. So a descriptive data is a dimension table. A descriptive data will have in the dimension table. So coming to the star schema. A star schema is nothing but there is a centrally located fact table and surrounded by the dimension tables. If you can see, there is a central sales underscore fact is the central fact table, and there are different dimension tables surrounded by this fact. Product dimension, customer, shipper, time, employee. So all these dimensions will directly connect to the fact table. Okay. If you see, the structure looks like a star. That is the reason it is called as a star schema. Coming to the snowflake schema. So basically Snowflake schema is also designed like star schema, but the difference is, if you can see, there is a time dimension table. The time dimension table again split into some other dimension tables. That means one dimension table will be divided into separate child dimension tables. Like if we see the time dimension table, we can split into the some year level dimension, then we can split into the month level, then we can see the day level. So we can say that the low level granularity we can maintain by using these dimension tables. Here in this, if you can see, time dimension is directly connected to the fact table, and the remaining child dimensions are not directly to the fact table. Okay, there is a snowflake. There is a snowflake has been created from the time dimension table. So this is called as a snowflake schema. We have to know what is what, nothing more than required from this. And galaxy, there is a third one, galaxy schema. So a galaxy schema is nothing but it's a combination of a star and snowflake. There are adding two or more schemas into a single schema is nothing but a galaxy schema. So you can see there, if you can see there are two fact tables connected by using the dimension tables. So the connecting the two fact tables is nothing but a fact constellation. Here I want to say one thing is, we cannot directly connect two fact tables because fact tables will not have the primary keys. Because fact tables will have only the numeric data and other keys. There is no possibility to connect one fact table to the another fact table. How can we connect the two fact tables is, we can connect through the dimension table. Like the A and B. These A and B are the dimension tables which are connected to the multiple fact tables. So these dimensions A and B are called as a conformed dimensions. Conformed. So this is the galaxy schema. Any questions in the schemas?
I only heard about star and snowflake schema. This is the first time I heard about galaxies.
Yeah, there is a third schema actually. So most of the organizations doesn't use it, but theoretically they don't talk about the galaxy, but most of the organizations will have the galaxy only.
Okay.
But they will call it as a star.
Got it.
So this is the data warehousing till now, and coming to the ETL development. So Datastage is an ETL tool, right? So what is E, what is T, what is L? E means extraction, extracting the data from relational sources, file sources, ERP sources, any other sources like the XML files, like the Excel sheets. We can read the data from any of the sources. That is nothing but an extraction of a source data. And then transformation. There are different kinds of transformations. These are the example 4 I have mentioned here. The data merging. Merging means if the data is there in one or two tables, then we have an option to merge it, right? There are two kinds of mergings again. Vertical merging and horizontal merging. If you see, if the structure of the data in two tables is the same, then we can merge the data in those two tables, right, into a single table. But if the structure of the data is different, then that is a different type of merging. It's coming into the joining part. We can use the key fields as a join keys, then we can merge it. That is the data merging concept. Cleansing the data. So sometimes we may require to cleanse the data as per the business requirement. Excuse me. And data scrubbing. So data scrubbing is nothing but deriving the new data definitions by using the existing fields. So we have some fields like for example, we have a salary and we have a commission. So based on the salary and commission, we can define a commission. We can define the tax. We can identify how much tax he's going to be paid. We can identify by using the different other fields like the salary and the commission. And the data aggregation, as I think you might aware. So aggregate functions like the sum, maximum, minimum, average. So these type of transformations we can do it. So these are just a rough four transformations I have mentioned. So we can perform a different kinds of functions in the data stage. And the last one is the data loading. There are two types of loading basically. Loading means it's just loading the data into the data warehouse. So there is an initial load and the incremental load. What does it mean by initial load is, whenever we develop a new application, we have to load the entire dump into the application, right? Because it's a new application, the production data is already there. So we have to take all the data and we have to dump it to the new application, new data warehouse. This is called the initial load. After completing the initial load, we will have an incremental load. That means only the changes to the existing systems will be loaded into the data warehouse. Keep on loading. Changes in the sense, if any updates in the source system or if any new records inserted in the source system, we will load those records into the data warehouse. That is called as a incremental load.
Okay.
So I just written in red color ETL. It's an ETL tool: extraction, transformation, and loading.
Okay.
Any questions?
No.
I think that's the end of the data warehouse fundamentals. So do you have any questions in the in all the slides? In any slide?
Actually, I don't have any question. You did a very good job explaining it.
Thank you. Thank you.
Where do
So,
you work?